Good morning, students. Welcome to video lecture on Artificial Intelligence and Machine Learning with Python. Subject code U18EC502A. Topic: Difference between Artificial Intelligence and Machine Learning, Regression and Classification, Linear Regression and Logistic Regression. Difference between Artificial Intelligence and Machine Learning. Artificial Intelligence is a technology which enables a machine to simulate human behavior. Machine learning is a subset of artificial intelligence which allows a machine to automatically learn from past data without programming explicitly. The goal of artificial intelligence is to make a smarter computer system like humans to solve complex problems. The goal of machine learning is to allow machines to learn from past data so that they can give accurate results. In AI, we can make intelligent systems to perform any task like a human. In ML, we teach machines with data to perform a particular task and given an accurate result. Machine learning and deep learning are the two main subsets of artificial intelligence. Deep learning is a main subset of machine learning. Artificial intelligence has very wide range of scope. Machine learning has a limited scope. AI is working to create an intelligent system which can perform various complex tasks. Machine learning is working to create machines that can perform only the specific tasks for which they are trained. AI system is concerned about maximizing the chances of success. Machine learning is mainly concerned about accuracy and patterns. The main applications of AI are Siri, customer supports using chatbots, expert system, online gaming, intelligent humanoid robots, etc. The main applications of machine learning are online product recommendation, Google search algorithms, Facebook auto-friend tagging suggestions, etc. On the basis of capabilities, AI can be divided into three types, which are weak AI, general AI, and strong AI. Machine learning can also be divided into three types. They are supervised learning, unsupervised learning, and reinforcement learning. It includes learning, reasoning, and self-correction. It includes learning and self-correction when introduced with new data. AI completely deals with structured, semi-structured, and unstructured data. Machine learning deals with structured and semi-structured data. The next is difference between regression and classification. In regression, the output variable must be of continuous nature or it is a real value. In classification, the output variable must be a discrete value. The task of the regression algorithm is to map the input variable x with the continuous output variable y. The task of classification algorithm is to map the input variable x with the discrete output variable y. Regression algorithms are used with continuous data. Classification algorithms are used with discrete data. In regression, we try to find out the best fit line which can predict the output more accurately. In classification, we try to find out the decision boundary which can divide the data set into different classes. Regression algorithms can be used to solve the regression problems such as weather prediction, and house price prediction. Classification algorithms can be used to solve the classification problems such as identification of spam mails, speech recognition, identification of cancer cells, etc. The regression algorithm can be further divided into linear and nonlinear regression. The classification can be divided into binary classifier and multi-class classifier. Uh, Regression algorithms are simple linear regression, multiple linear regression, and polynomial regression. The classification algorithms are logistic, k nearest neighbor, support vector machine, kernel-based SVM. Here the kernel is used for dimensionality based solutions. The next is Naive-Bayes algorithm, decision tree classification, random forest classification. Here you can observe based on the scattering diagram here how this particular regression line best fits to the given data. Here initially the algorithm takes some random line, and after a few iterations this particular line will be best fit to the data in such a way that uh, the machine learning model accuracy can be increased. And in classification problem, you can observe it is a support vector machine which classifies to group of data with the help of hyperplane. It is support vector machine algorithm for data classification. The difference between linear regression and logistic regression. Linear regression is used to predict the continuous dependent variable using a given set of independent variables. Logistic regression is used to predict the categorical dependent variable using a given set of independent variables. Regression is used for solving regression problem. Logistic regression is used for solving classification problems. In linear regression, we predict the value of continuous variable. In logistic regression, we predict the value of categorical variables. Here, the linear regression comes under general regression uh, problem, and here logistic regression comes under classification problem. In linear regression, we find the best fit line by which we can easily predict the output. The logistic regression, we find the S curve by which we can classify the samples. Least square estimation method is used for estimation of accuracy. In case of linear regression, in case of logistic regression, maximum likelihood estimation method is used for estimation of accuracy. The output for linear regression must be a continuous value such as a price, age, and etc. The output of logistic regression must be a categorical data such as 0, 1, yes, no, etc. Here, the next is in linear regression, it is required that relation between the dependent variable and independent variable must be linear. That is, if the data, the scattering diagram is linear, then we can apply linear regression algorithm. The scattering diagram is non-linear, then we go for polynomial regression. In logistic regression, it is not required to have the linear relationship between the dependent and independent variables. In linear regression, there may be a collinearity between the independent variables. Uh, in logistic regression, there should not be collinearity between the independent variables. Here you can observe how the linear regression and logistic regression can be applied. Now here this particular graph is a sigmoid curve. Thank you. We will meet with the next lecture.